Welcome students. Welcome to St. Joseph's open web-based learning platform. So we learn for a soulful and enriching e-learning experience. Welcome to Department of Mathematics. Our topic name is differential equations. Instructor for this chapter B. Bharati, MSc Mathematics, Assistant Professor, Department of Mathematics, St. Joseph's College for Women, Autonomous, Vishakhapatnam. Learning outcomes. By the end of this chapter, students will able to identify and solve a separable differential equation by using integration to find a general solution. Second point, students learn to manipulate equations, choose appropriate integration techniques. Third point, students learn to understand the behavior and characteristics of the solutions. Let's see the content. Introduction, definition of separable variable method, working rule to solve separable variable method, related examples. Introduction to differential equations with separable variable method. Variable separable method is used for both ordinary and partial differential equations. For ordinary differential equations, first, the variables are explicitly separated and written with their respective derivative. Then we simply integrate the equation formed to get the required solution. For a partial differential equations, the variables are separated with the help of some simple substitutions, making the equation a combined form of different ordinary differential equations and then integrating them to get the required result. Definition of separable differential equations. Separable differential equations are a special type of ordinary differential equation. Sometimes we used to write ODE that can be solved by separating the variables and integrating each side separately. Any differential equation that can be written in the form of y dash is equals to f of x into g of y is called a separable differential equation. Y dash can also be written as dy by dx is equals to f of x into g of y, where f of x and g of y are two continuous functions of x and y which are defined on an interval. In this slide, we are going to see working rule to solve variable separable method. Consider equation dy by dx is equals to xy, where x is a function of small x and y is a function of small y. First step, given differential equation is dy by dx is equals to x into y, where x and y are the functions of small x and small y. Second step, variables have been separated, that is dy by y is equals to x into dx. Third step, integrating on both the sides, that is integrating means apply integral on both the sides. Integral 1 by y into dy is equals to integral x into dx plus c, where c is an arbitrary constant. Come to the fourth step. Then we get general solution of the given differential equation. We can easily solve these types of equations by simply separating the variables in the differential equation and then integrating them individually. Let us see the example 1. Solve the differential equation x into dy minus y into dx is equals to 0. First write down given equation as it is. X into dy minus y into dx is equals to 0. Next step what we did means send minus y into dx to the right side part. Then it becomes x into dy is equals to y into dx. Next step, we are going to separating the variables. dy by y is equals to dx by x. Next, applying or taking integrating on both the sides. So integral 1 by y into dy is equals to integral 1 by x into dx. As we know, the formula for integral 1 by y into dy is equals to log y. So we written this thing as log y is equals to, and same integral 1 by x into dx formula is log x plus log c. Here we treated log c as some constant, and write down log y as it is equals to, the above value looks like log a plus log b. We have a formula for log a plus log b, that is log of ab. So this thing can be written as log of x into c, taking anti-logarithm on both the sides. Then we directly got y is equals to x into c. Let us solve the example 2. Solve the differential equation dy by dx is equals to 1 plus x squared by y. First write down given equation as it is. That means given that dy by dx is equals to 1 plus x squared by y. Next step, what we did means send denominator part of dx to the right side part. Then we got dy is equals to 1 plus x square by y into dx. Next step, we are going to separate the variables x as one side and y variables as another side. So we written y into dy is equals to 1 plus x square into dx. Next, in taking integrating on both the sides. So integral y into dy plus square into dx. Before going to solve this part, look into the since part. Integral x power n into dx is equals to x to the power of n plus 1 by n plus 1. Whereas here we are going to apply this formula for these two integrals. So integral y can be written as, using this formula, y square by 2 is equals to integral 1 into dx becomes x plus integral x square, means after using this formula we got x cube by 3 plus c. Therefore, general solution of given differential equation is y square by 2 is equals to x plus x cube by 3 plus c. Let us solve example 3. Solve the differential equation e power y into dy by dx is equals to x square. So first write down given equation e power y into dy by dx is equals to x square. Let's move on to the next line. Separating variables x as one side and other variables on another side. So it can be written as e power y into dy is equals to x square into dx. Next line we are going to taking integrating on both the sides. So applying integral e power y into dy is equals to integral x square into dx. Next step, integral e power y formula is e power y is equals to integral x square dx. As we seen in the previous slide, integral x power n can be written as x to the power of n plus 1 by n plus 1, using same formula here. So integral x square dx becomes x cube by 3 plus c. Therefore, general solution is e power y is equals to x cube by 3 plus c. Let us see the example 4. Given question is, solve the differential equation dy by dx is equals to cos of x minus y. First write down given equation, that is dy by dx is equals to cos of x minus y, and let it be equation 1. Next line, we are going to give a name for x minus y, say v. Let x minus y is equals to v. Move on to the next line. We are going to do derivative on both the sides with respect to x. So first value x becomes 1 with respect to x, minus dy by dx is equals to dv by dx. Whereas in the next line what we did means send minus dy by dx to the right hand side and bring dv by dx to the left side part. Then it becomes dy by dx is equals to 1 minus dv by dx. Next line, by using equation 1, we already know the value of dy by dx is cos of x minus y. Just directly substitute here cos of x minus y. But we already gave a name for x minus y as we know. Just substitute. It becomes cos v is equals to 1 minus dv by dx. Next line, again send minus dv by dx to the left side part and send cos v to the right hand side. Then it becomes dv by dx is equals to 1 minus cos v. In this slide, we are going to separating the variables. That means write down v variables as one side and x variables as another side. That is dv by 1 minus cos v is equals to dx. Move on to the next line. What we did here means we are going to apply integral on both the sides. So integral 1 by 1 minus cos v into dv is equals to integral dx. Next line, if you look into the next line, integral dv by 2 sine square of v by 2 is equals to integral dx. If you look into the left side part of integral, in place of 1 minus cos v, we directly substitute 2 sine square of v by 2. No? How we directly written this means, in half angles, triangles, we have a 3 formulas for cos x. One of the formula of cos x is 2 cos square x by 2 minus 1. By using this formula, we can write 1 minus cos x value is 2 cos square x by 2. So finally, by using this formula, we are going to replace with 2 cos square x by 2 in place of 1 minus cos v. That is how we got the second line. Move on to the next, that is how we got the third line. Move on to the next line. Take out 1 by 2 outside of the integral. Integral 1 by sine square of v by 2 is nothing but cosecant square of v by 2 into dv is equals to integral dx is nothing but x plus c. Next line, write down 1 by 2 as it is again, and integral of cosecant square of v by 2 into dv formula is minus cot v by 2 by inner derivative is 1 by 2 is equals to x plus c. Here 2 get cancelled. The leftover part on the left hand side is minus cot of v by 2 is equals to x plus c. Move on to the next step. Again, we are going to substitute the value of v, that is x minus y, in the above equation. Minus cot of, instead of v, we already gave name for v as x minus y, no? So minus cot of x minus y by 2 is equals to x plus c. Therefore, general solution of the given differential equation is minus cot of x minus y by 2 is equals to x plus c. So this is the general solution of the given differential equation. Next, move on to the example 5. Here given question is, solve the differential equation 9y into y dash plus 4x is equals to 0. First write down given equation as it is, that is 9y into y dash plus 4x is equals to 0. Move on to the next line. Write down 9y as it is. Instead of y dash, another form of y dash is dy by dx, and send plus 4x to the right side part, then it becomes minus 4x. Finally we written this line as 9y into dy by dx is equals to minus 4x. Move on to the next line. What we did here means separating the variables x as one side and y variables as another side. Nothing but 9y into dy is equals to minus 4x into dx. Next line, write down 9y into dy as it is. Again bring minus 4x into dx to the right left hand side. Then it becomes plus 4x into dx is equals to 0. In previous slide, we already separating the variables x as one side and y as another side, whereas in this slide we are going to apply integral on both the sides. That is integral 9y into dy plus integral 4x into dx is equals to integral 0 into dx. Move on to the next line. 9 is constant, so take outside the integral. 9 into integral y dy plus 4 is a constant, so take outside 4 into integral x into dx is equals to integral of any constant terms becomes c. Move on to the next line. 9 into integral of y into dy can be written as y square by 2 plus 4 into again integral x into dx can be written as x square by 2 is equals to c. No, how did we get this line means, if you look into this condition, integral x power n into dx formula is x to the power of n plus 1 by n plus 1. By using this formula, we can write integral y into dy as y square by 2 plus apply same formula for integral x into dx, it becomes x square by 2. So that is how we got this line. Next line, if you take LCM throughout this inequality, we got 2 and send 2 to the right side part. Then it becomes 9y square plus 4x square is equals to 2x. Rearrange this line. 4x square plus 9y square is equals to 2c, where c is a constant. This next required solution of this equation is 4x square plus 9y square is equals to 2c. Thank you all for sparing your valuable time.